We are taking R.D. Sharma Solution Class 12th. Chapter is 19 MCQ multiple choice questions for indefinite integrals. Now this question also has the same approach as we have done in the previous question. Whenever we see this e raise x, we have to apply that result, which we already know. We also have this tan x by 2 and cot x by 2. That means we have to change this to some sort of this tan x by 2 or cot x by 2. So this 1 by 1 minus cos x I am separating because 1 minus sin x can be taken like this, 1 by 1 minus cos x minus sin x divided by 1 minus cos x. Now this 1 minus cos 2 theta or 1 minus cos 2x is 2 sin square x by 2. That is, whichever angle is on the left, it will be half of that. So 1 minus cos x can be written as 2 sin square x by 2. Then we have this sin x. Sin x by 1 minus cos x, sin 2x is what? 2 sin x cos x. We can apply this here. Sin x is 2 sin x by 2 cos x by 2. So let's use this 2 sin x by 2 and cos x by 2 for sin x. In the denominator, again 1 minus cos x will remain same, 2 sin square x by 2 here. So what is the benefit? First, this half sin square x by 2 we can take upstairs, so it can be cos x square x by 2. It will be actually. This 2 you can cancel, 1 sin you can cancel. So sin x by 2 here in the numerator is vanished. Only cos x by 2 divided by sin x by 2 remains. So cos by sin is cot. So we write cot x by 2 here. Now we are approaching because we want to integrate now. E raise x is already there. Now we are integrating. But one thing which I see here is I want to match it with e raise x fx plus f dash x. For that we need fx first and then f dash x second. That's what is the default trivial things which we were doing earlier. The result will be e raise x fx after the integration. But fx cannot be taken as half cos x square x by 2. Fx will take as cot x by 2. So it has a negative outside. So we can take a negative all of it from both of them. We can take a negative outside. So the places can be swapped. So when you take a negative outside, it will be cot x by 2 minus half cos x square x by 2. So I'm taking a negative outside, which I just explained you why I'm doing this. I'm taking a negative outside. Now we'll have a proper way of fx and f dash x. Because fx, if it is taken as cot x by 2, we definitely know that f dash x will be cos x square x by 2 half. Let's do it here also. Just to complete the question, fx equals to cot x by 2. And when you're going to differentiate it, it will give you negative cos x square x by 2 and differentiation of x by 2 will be half. This is half. So minus half cos x square x by 2. That is what f dash x means. Fx is cot x by 2. The direct result is e raise x fx plus constant of integration. E raise x remains here. Negative we have taken outside. Fx is cot x by 2 plus a constant of integration. That's your final result. Which one of this is correct? You can match it. So we have no half here. Negative cot x by 2, which is the second one. B is the correct result. Now this is how it will be done. This is the whole process and which I explained you internally also. We have to apply this one. We have 2 divided by e raise x plus e raise negative x. So let me write it as 1 by e raise x and it is square. So 2 divided by, we have e raise 2x plus 1 divided by e raise 2x. Now this is square. Please remember it's ex square. So when it goes up, it will be e raise x square. So the numerator became 2 raise e raise 2x 1 plus e raise 2x. And this is whole square. Now we have to integrate it. So 1 plus e raise 2x. If we take it as t, this dt by dx will be equal to e raise 2x and then differentiation of 2x will be 2. So we have got 2 raise e raise 2x dx already in terms of dt. So numerator will replace it by dt. Denominator we have taken as 1 plus e raise 2x, so it will be t square. And integration of t square you already know. So t raise minus 2 plus 1 divided by negative 2 plus 1. It will be negative 1 by t. You already know that. So I'm writing it after the integration, negative 1 by t plus a constant of integration. But what was t? If you remember, it is negative 1 by 1 plus e raised 2x plus constant of integration. But incidentally, we are not getting the answer here. So we have to change this answer in order to match one of the 4 options. How can it be done? Because we need to match them, right? 1 by 1 plus e raised 2x is not the answer. Divide numerator denominator by e raise x. So first one will become e raise negative x with a negative sign. This become e raise negative x and this e raise x, e raise 2x will give you e raise x plus a constant of integration. Now is it matching? Just see, it's matching. Yes, it's matching. with the first option. Okay, this one is the correct one. You can link it with A, or if MCQ comes, this is the answer. So this is the formal way of doing it. It's a tricky question, remember, because you have to divide it by e raise x in the last or at the conclusion point. Next one is e raise x 1 plus x divided by cos square x e raise x. So whenever we have e raise x, it's quite possible that we can apply that result, general result. Now we already know that x into e raise x, it gives you that e raise x 1 plus x, because we have the prior knowledge of differentiation. So when we take t equals to x into e raise x and you differentiate it, it will be x into e raise x plus e raise x, because we have applied the product rule. Now when you take this e raise x out, it will be e raise x plus 1. Dx can be brought on the left. So dt becomes the numerator here. This whole numerator has now transformed into dt only. So the integration in terms of t can be written as dt divided by cos square x e raise x was already taken as t. So it's simply cos square t. Now cos square t is simply sec square x t dt. Now sec square t, direct integration is 10t, which is t should be inside the modulus. But t was taken as x e raise x, so write 10x raise e x plus constant of integration. That is your final result. You can match it with the C one. C. So this is the process you are going to adopt, and this is quite awareness. If you are aware of the differentiation, you can do it easily. Now whenever we have the difference of the power, that is we have sin square x divided by cos raise 4x. Since 2 and 4 is there, you ought to have something to do with the difference in the power. So take the equal powers first and then separate out the remaining power. What does it mean? Sin square x is there. I am writing cos raise 4x as cos square x into cos square x. Now when you integrate this, sin square x by cos square x will be tan square x. 1 by cos square x will be sec square x. Integration dx. Now we are ready for it. But when you take t equals to 10x, sec square x will automatically come, because dt by dx is sec square x. You can take this dt equals to sec square x dx. So dt will come like this. So this integration will be d sec square x dx is dt. Tan square x is simply t square. So t cube by 3 will come with a plus a constant of integration. So t was tan x, so tan cube x divided by 3 plus a constant of integration. So you can match this. Third one is the correct answer. So this is quite easy for you. I hope you'll be able to do it by yourself. The primitive of the function fx equals to 1 minus 1 by x square a to the power x plus 1 by x when a is greater than 0 is. Alright. Now what is primitive? It's simply integration. What is the integral of this function? And from this question, we are self-aware that x plus 1 by x will give you what? We know that x plus 1 by x, if it is differentiated, 1 minus 1 by x square will be the result. So this fx, if it is taken as x plus 1 by x and we try to find out f dash x or d by dx, it will be 1 minus 1 by x square. So this integration of 1 minus 1 by x square, a to the power x plus 1 by x if we want to do, and a is greater than 0, x plus 1 by x if we take it as t, dt equals to 1 minus 1 by x square into dx. So this, if you have a dx and 1 minus 1 by x square here, it can be simply written as dt. A raised power x plus 1 by x was just taken as t. So a raised t dt is what we have to do. A raised x integration is very simple. A raised x divided by log a. The base has to be e plus a constant of integration. So a raised t divided by log e a plus constant of integration. E is the base. Only one thing is remaining. T has to be replaced by x plus 1 by x in the final result. A raised x plus 1 by x log a in the denominator. Match it and you'll see that there is no x here. Only the first one is the correct one. Alright. So this is your final result. So it's a good question, because those who are experienced with the differentiation will easily catch what we have to do here. Integration of 1 by x plus x log x. We can take this x outside. Just take x and you will see what will happen. So I am taking x out of this 1 plus log x only will remain. Integration of dx divided by x plus x into 1 plus log x. Now when you take this 1 plus log x as t, this dt by dx will be what? 1 will be 0, log x will be 1 by x. So this dt will be equal to dx by x. Now dx by x is already in the question. This is already there. So what we can do? 1 by t dt and will be simply log modulus of t plus constant of integration. Now t was taken as 1 plus log x. So just replace this 1 plus log x plus constant of integration. So the answer is the last one. D is the correct option. Log 1 plus log x. This one. So this question is quite straightforward. If you happen to take x from the denominator, it will be very easy for you. Now under root x by under root 1 minus x dx. Now all of these have sine inverse in the front. All the options. That means you have to do something with this sine inverse content. So x 1 minus x. We will use the trigonometric identities or the results. If you take root x equals to sine theta, x will be equal to sine square theta. When you differentiate this dx by d theta, if you differentiate both the sides, it will be 2 sine theta. Then the differentiation of sine theta will be cos theta. So it will be sine 2 theta. So dx has become sine 2 theta d theta. So what is the benefit? We will see just now. X will be equal to sine square theta. Now integration will change like this. In place of x, we will write sine square theta. In the denominator, we will write 1 minus sine square theta. 1 minus sine square theta is cos square theta. Sine square theta by cos square theta is tan square theta. Under root tan square theta is just tan theta. That means if I write sine square theta in place of 1 minus cos square sine square theta, I am writing cos square theta. Under root sine square theta by cos theta can be written as sine theta by cos theta. Or you can write it as tan theta. But will this tan theta gives us something? I don't think, because this dx has to be utilized. So dx equals to sine 2 theta. I am writing sine 2 theta is 2 sine theta cos theta. Let's forget about that tan theta thing which I just uttered. So 2 sine square theta will come. Cos theta will get cancelled. 2 sine square theta will come. 2 sine square theta has a direct formula, integration of 1 minus cos theta. Alright. So 1 minus cos theta, let's separate them out. Integration of d theta minus integration of cos 2 theta. D theta. D theta integration will be theta minus cos 2 theta will be what? Sine 2 theta. Differentiation of 2 theta will be 2. So it has to be divided. So it's sine 2 theta divided by 2 plus a constant of integration. Now what is the final thing? We have to replace theta. We have introduced it by ourselves. So we have theta minus 2 sine theta cos theta in place of sine 2 theta. We write 2 sine theta cos theta. You can cancel these 2 out. So you have to write the answer like this. Theta minus sine theta cos theta plus a constant of integration. Now sine theta cos theta will be replaced like this. Because x is sine square theta. Sine theta will be what? Root x. Cos theta will be under root 1 minus sine square theta. So under root 1 minus sine square theta is already x. So under root 1 minus x will be there. Sine square theta plus cos square theta is 1. That's why cos square theta can be written as, or cos theta can be written as under root 1 minus x. That's what we are going to use here. Theta minus sine theta under root in place of cos theta, I am writing under root 1 minus sine square theta plus constant of integration. Theta initially, because root x was taken as sine theta. So theta will be equal to sine inverse. Alright, sine theta is root x. 1 minus sine square theta is under root 1 minus x. What is sine? What is theta? It's sine inverse root x plus constant of integration. So this is inside the bracket. It will be sine inverse root x minus root x into root 1 minus x. You can take root x common if you want. You don't want it. Let it be like this. Plus constant of integration. I just have to match it with any of the options which are provided. So which one is the correct one? Sine inverse under root x minus under root x minus x into 1 minus x. So this is how it will be done, and this is how the result will come. Alright, you have to match it with, because this question needs some effort. Now do you want me to do this, or it's clear to you? The result is e raise x fx. We have already discussed this and proven it while we were approaching to these questions. So even if you want to have a look, this is the description for you. Sin x plus cos x by under root 1 minus sin 2x. So we have done a question, this one in this exercise only, because we know that this denominator can be converted into something which relates to the numerator. I am writing this one as sin square theta plus cos square theta, or sin square x plus cos square x. Sin 2x can be written as 2 sin x cos x. This is simply sin x minus cos x whole square. Means a square plus b square minus 2ab is a minus b whole square. So sin x minus cos x whole square under root of this. Now root of 2 will get cancelled, only sin x minus cos x will remain. So this integration will be sin x plus cos x will remain in the numerator. Denominator is sin x minus cos x. And since sin x minus cos x gives you directly sin x plus cos x, if you take the differentiation of the denominator. So take this t, and please remember, whenever you get rid of the root, plus minus will come, because under root x square, it can be plus x square, it can be negative x square. So always remember to put plus and minus sign. Wherever I have left in the previous questions, please add it. because in this question we see that the answer comes in plus minus the last two options. So we have sin x minus cos x. I am differentiating it. Dt by dx is cos x plus sin x. Dt will be equal to cos x plus sin x dx, which is the numerator, of course. So plus minus sin x plus cos x dx is dt. Sin x minus cos x is t. Integration of this is simply log t. Plus minus remains as it is because we have removed an under root. Log modulus t plus constant of integration. T was taken as sin x minus cos x. Just replace it here. So it will be plus minus log sin x minus cos x plus constant of integration. And you can match it. It is the last option which you see here. Alright, it is matching exactly. So this is how this will be done. So this is the process. If you have to write it, then you write it like this. This question will be taken in the next discussion. Till then, thank you so much. Have a good one.